This video is for lesson 15-2, trapezoids. Learning goals are to develop some properties of trapezoids and prove those properties. A trapezoid is a quadrilateral with exactly one pair of parallel sides. The parallel sides are called bases, and the non-parallel sides are called legs. The pairs of consecutive angles that include each base are called the base angles. So number one, sketch trapezoid, TRAP, and identify the bases, legs, and pairs of base angles. So as this is drawn, that is parallel to that. Those are the bases. The other two sides, the ones that are not parallel, are called legs. The angle formed by a leg and a base, like that angle and that angle, or that angle there and that angle there, those are called the base angles. The median of a trapezoid is a segment with endpoints at the midpoint of each leg of the trapezoid. So you see in the drawing the original trapezoid, ignore the purple line for now. Point M is the midpoint of that side, and point N is the midpoint of that side. Segment MN is called the median of the trapezoid. There's a theorem about that called the trapezoid median theorem. It says the median of a trapezoid is parallel to the bases, and its length is the average of the length of the bases. So here we have a proof of this. Given trapezoid EFGH, and that segment MN, right across here, is the median. Let's prove that it's parallel to FG and to EH, and let's prove that its length is half of the sum of the bases. So number two, draw one diagonal in the trapezoid. I did that in purple. I could have drawn the diagonal from F to H. I chose to draw the one from E to G. And it says label this point right here X. Explain how the triangle midsegment theorem can be used to justify the trapezoid medium theorem. My explanation has a few steps, and the main ideas are over here on the right. With the triangle midsegment theorem from the previous lesson, we can show that that length from M to X is half of the length from F to G in this triangle. And we can show that this length from X to N is half of EH. So looking at this triangle on the right, its triangle midsegment is half of the third side. Let's put these together. If we add together MX and XN to create the entire brown segment, that would equal to half FG plus half EH. MX plus XN is MN, and adding these together is 1/2 FG plus EH. So this is showing that the median of the trapezoid, MN in this drawing, is half of the sum of the bases. And now we know why in yesterday's lesson, even though we were discussing kites, we also had the triangle midsegment theorem because we needed that theorem to prove this new theorem about trapezoids. Given that trapezoid EFGH and that segment MN is the median, so that same trapezoid from that figure there, let's find the following. Question A. If angle GFE is 42, then what is angle NME? So GFE, if that angle is 42 degrees, what is angle NME? So NME, this angle right here. Well, because these are parallel and these angles are corresponding, that's 42 degrees as well. And that's filled in. What about angle MEH? So angle MEH is this one here, this obtuse angle. If that's 42 degrees, then how much is this? These are consecutive interior angles between the parallel lines, and so they are supplementary. It must be 138, because 42 plus 138 is 180. Question B, write an equation and solve for X if we have an expression for FG, for EH, and for MN. Looking at that drawing, FG is one of the bases, EH is one of the bases, and MN is the median. So it was that trapezoid medium theorem that we would use as the relationship, that MN is equal to half the sum of the bases. And with that idea, we can create this equation. 22 is the MN, and that is equal to half the sum of the two bases. Solve out this algebra, we get x equals 7. Okay, one more question. This time, let's make believe that MN is 19 and EH is 12, and we want to find FG. So again, FG is a base. MN is the median, and EH is the base. The median is equal to half the sum of the bases. With that idea, we can create this equation and then solve the algebra out to find that FG is 26. 19 is the average of 12 and 26. Number 4, what property or postulate allows us to draw that auxiliary line in this question? So when we drew the purple line from E to G, why are we even allowed to do that? Well, there is a postulate in geometry that says between any 2 points, like E and G, there is exactly one line. And so I have written that postulate out as the answer to number 4. Here are some check your understanding questions, so I'll pause the video. Now here's another vocabulary term for the lesson. An isosceles trapezoid is a trapezoid with congruent legs. So number 7, given triangle ABC is isosceles, and AB, so that left side, is equal to CB, the right side, and given that AD, that little chunk, is equal to CE, let's answer some questions. Angle A is congruent to what angle? What angle is equal to that one? And that would be angle C, because the base angles of an isosceles triangle are congruent. That was a theorem from a previous lesson. Now, question B, explain why triangle BDE, so that top one, is isosceles. And the reasoning goes something like this. Because AB is equal to CB, so because that entire length is equal to that entire length, and because this piece is equal to this piece, if we subtract those equal sized pieces from the longer sides, we would be left with those top pieces, and they would be congruent. Question C, segment AC, the bottom, is parallel to what? And the answer would be segment DE. And explain why. And the answer has to do with how angle BDE, this angle here, is congruent to this angle here, and these are in corresponding positions. So when corresponding angles on the lines are congruent, then we know that the lines are parallel. Question D, explain why quadrilateral ADEC, so this bottom chunk right there, why is that an isosceles trapezoid? Well, to be an isosceles trapezoid, it has to have some parallel sides, and it has to have congruent legs. And that's what we had proved in earlier questions. We showed that DE and AC were parallel, and we showed that AD was congruent to EC. Question E, angle ADE, ADE, so this angle in here is congruent to which other angle? And that answer is this one, CED, because base angles of an isosceles trapezoid are congruent. And so question F just asks for a repeat of that idea. The base angles of an isosceles trapezoid are congruent. Number 8, on grid paper, plot quadrilateral COLD with these coordinates. Notice that I've done that in green, COLD, and I've connected them together to make a four-sided shape. show that quadrilateral, COLD, is a trapezoid. To do this, think about what a trapezoid has. It has one pair of parallel sides. So what I wanted to do is I wanted to show that that segment was parallel to that segment. And because it's on a grid, we can do that with slopes. The slope of OC is rise 1, run 3, 1/3. And the slope of CD is to rise 2 and run 6. But that reduces to 1/3 as well. So because those have the same slope, they are a pair of parallel sides. That's why we know it's a trapezoid. Question B, show that it's isosceles. So think about what an isosceles trapezoid has. It has congruent legs. So this time we want to show that this leg from C to O is the same length as this leg from L to D. So we use the distance formula. That involves a square root. And remember how it's the change in x squared plus the change in y squared? This distance turns out to be the square root of 5 units. And this distance is the square root of 5 units. That shows that it's isosceles. Question C, identify and find the length of each diagonal. So one diagonal runs from O to D. It's segment OD. So what's its length? Well, because that's horizontal, we could just count the units. 1, 2, 3, 4, 5. That's 5 units long. The other diagonal runs from C up to the L. So it's diagonal CL. Let's find its distance. Square root. Okay, let's find the difference of the x-coordinates. This x-coordinate is at 1, and this x-coordinate is at 5, and so the difference is 4 units. Plus, now let's do the difference of the y-coordinates. This y-coordinate is at 0, and this one here is at 3, so the difference of the y-coordinates is 3. Now let's simplify this square root. 4 squared is 16, 3 squared is 9. That makes 25, and the square root of 25 is 5. Based on those results, complete the theorem. The diagonals of an isosceles triangle are congruent. Question 9. At this point, the theorem in item 8 is simply a conjecture based on this one example. Let's write the key steps for a proof of this theorem, because once we prove it, we can then use the theorem for the rest of geometry class. So here we have a isosceles trapezoid, C-O-R-E, and I traced over part of it. It got a little offset here for some reason, something got bumped. But imagine that the green triangle is tracing C-O-E, that the red triangle is tracing the R-C-E. I'm sorry about whatever bumped it over a little bit to the left. I don't know how that happened. Okay, the key steps of showing that the diagonals are congruent are to show that the green triangle is congruent to the red triangle, and we can do that with side angle side. That side is congruent to that side. They share a side, so certainly that's congruent to itself, and we know that that base angle is congruent to that base angle, so side angle side. Once we know that those two triangles are congruent, then we know that that side is the same length as that side, because corresponding parts of congruent triangles are congruent. And this shows that those brown diagonals are congruent to each other. Here are some check your understanding questions, so I'll pause the video. In this lesson, we developed and proved some properties of trapezoids. One involved the median of a trapezoid, that it is parallel to the bases, and that the length of the median is half of the sum of the bases. We also showed that for an isosceles trapezoid, that the diagonals are congruent to each other.